Hi, once again, thank you for watching our video. In this question, we will be expanding using binomial expansion where the powers are to a negative integer. Now, in this question, we are asked to express this expression f of x in partial fraction. And then we are supposed to expand this up to the x cubed term. This should be cubed. And then show that the coefficient of x to the power n is given by this, where n is a positive integer. Now we learned in Sec 4 how to break down this expression in a form of a partial fraction. Now f of x can be written as a over x minus 2 square plus b over x minus 2 plus c over x plus 1. Now we can use cover-up rule to find what's the value of a and c. But for this exercise, I will just do the normal way like what you have done in Sec 4. I know that some of you may not know cover-up rule. So you express this as a single fraction, then you will find that the denominator is the same as this. So then the numerator, since the denominator are equal, so the numerator will be equal as well. Therefore, a into x plus 1 plus b into x minus 2 times x plus 1 plus c into x minus 2 squared. And you find that this is equals to 3. Now, you can find the value of a, b, and c by comparing coefficient or by substituting suitable values of x. Like if you put x is 2, you will find that this 2 is 0, whereas 3a is equals to 3 and a is equals to 1. Now I will not bore you with the workings to find out the values of a, b, and c, since you already know it in Sec 3 or Sec 4. So you will find that a will be equals to 1, b is equals to minus 1/3, and c is equals to 1/3. Now so f of x can be written as 1 over x minus 2 squared minus 1 over 3 x minus 2 plus 1 over 3 into x plus 1. Now we are asked to expand this expression to the x cubed terms. Now, since this can be expressed as this, it's so much easier to expand this way. So what we do is we consider this expansion for this term first. So what do you have over here? You have x minus 2 to the power of minus 2. Now how to expand this? Now for this we can use the binomial series expansion. 1 plus x to the power n will give you nc0 plus nc1 x plus nc2 x squared plus NC3 x cubed, so on and so forth. Now, we must make sure that this expansion, when you expand it, all right, this expansion must be in ascending powers of x. Now, how to make sure that this is ascending powers of x? You have to put the numeral in front, followed by x, because if you put the x behind, then you will find that you use this expression, the binomial series expansion, you find that this powers of x is increasing. So we need to put this way. Now, the other thing to take note is, if you want to use this expansion, now then you must make sure this is 1. So to make sure this is 1, you divide by -2 throughout. Alright? So you have 1 minus x over 2 to the power of -2. Now you take 2 to the power of -2 out. So what will you get? Over here you get 1/4. 1 minus x over 2 to the power of -2. Now let me expand this. This will have a quarter. This have NC0 is 1 plus NC1 is -2 into minus x over 2. Now then you have NC2. NC2 is -2 minus 3 over 2 factorial, that is 2. Then you have -2 over 2 square. Then you have plus -2 minus 3 minus 4 over 2 times 3, this is 3 factorial. Now into minus x over 2 cube plus ... close bracket. Now we can simplify this. You have a quarter, 1 plus x. This is also plus. This and this can cancel. You have 3 over 4x squared. Now this is also plus, so this and this can cancel. Now this is a plus as well. This x over 2, the denominator becomes 8 because you cube. Then you times the -4, you will have half. So you got x cubed over 2 plus ... close bracket. Then now you multiply the 1/4 inside, so you get 1/4 plus x over 4 plus 3 over 16 x squared plus x cubed over 8. Okay, plus ... Okay, I have finished expanding the first term. Let's now move on to expand the second and third term. But before that, let me erase this part. Okay, let's now try to expand the second term. So you have minus 1 over 3 times x minus 2. This one can be rewritten as minus 1/3 x times x minus 2 to the power of -1. Now you want this to be in ascending powers of x. Just like this, you have to put the x behind. So now, so you got 1/3 minus 2 plus x to the power of minus 1. Now, how to expand this? Now, now for this, you can use either this, all right, or there is a standard expansion for 1 plus x to the power of minus 1. There's a standard expansion. Now, if you are taking the A level under your Maclaurin series expansion, you have this expansion and you can make use of it. Now, for the higher level math, those people who is taking the higher level math in the IB syllabus, then you can use this formula to do this expansion. All right, but you have to make sure that the coefficient is 1. Now, what is the expansion for this? This is 1 minus x plus x squared minus x cubed plus dot 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 dot. Now, so the expansion for this is 1. So you have to make sure that this term is 1. So what do we have over here? I think I miss out a minus here. All right. So you have minus 1/3 minus 2 plus x to the power of minus 1. So you take the you take the minus 2 out. So, but it's to the power of minus 1. So this will then become 1/6 because you must times half. What do you have here? You have 1 minus x over 2 to the power of minus 1. Now, so you can use this expansion, this standard expansion, all right, to get the answer for this. So you have 1/6 into 1 plus x over 2 plus x squared over 4 plus x cubed over 8 plus dot dot dot. Now you multiply the 1/6 inside, what do you get? You got 1 over 6 plus x over 12 plus x squared over 24 plus x cubed over 48 plus dot dot dot. Okay. Now how about this term? Now for the last term, we have 1 over 3 to the power of 1 plus x. All right, x plus 1 is same as x, 1 plus x. So this, what will we get? We get 1/3 into 1 plus x to the power of minus 1. Now you can use this standard expansion. You have 1/3. This is 1 minus x plus x squared minus x cubed plus dot dot dot. Now you multiply the 1/3 inside, you have 1 over 3 minus x over 3 plus x squared over 3 minus x cubed over 3. Now to find the expansion of this up to the x cubed term, we need to add this part here to this part and then to this part, and that will get the answer. So f of x is approximately equals to, now because I'm ignoring the term that has the term that is, now so we will find that f of x will be approximately equals to Now why approximate? Because I'm ignoring the terms whose power is greater than x cubed. Now I will not bore you with the detailed working, but if you add all these up, you will get 3 over 4 plus 9 over 16 x squared minus 3 over 16 x cubed plus. You can leave the answer as this. Alright, if you leave the answer as this, then this will be approximate. If you add the dot dot dot, then this will be equal. Okay? We have come to the last part of question 2. Now for the last part of question 2, you are asked to show that the coefficient of the term in x to the power of n can be written in this form, where n is a positive integer. Now your expression of f of x is as such. Looking at this, it's quite hard to derive this from this. There's almost no pattern. Therefore, we have to look at the individual expansion. And after that, we add all of them up, and hopefully we can come to this. Now let's look at this expansion first. So for minus 2 plus x to the power of minus 2. Now for coefficient of x to the power n, let's look at this. Now you want n to be a positive integer. So you only start looking at this term, because over here is x to the power of 0. Alright, you want at least n to be at least 1. So you look at this. Now, this is the first term. This is the second term. And this is the third term. Third term as in n is 1, n is 2, n is 3. But it's the fourth term in this expansion. So when I say first term means when n is 1. So when n is 1, you look at this. Over here, it appears 1. Whereas when n is 2, this is to the power of 2. When n is 3, this is minus half to the power of 3. So you have minus half to the power of n. Now how about the number in front of it? Here n is 1. Alright, n is 1. And n is 2. So you realize this is minus n minus 1. Now, but if you look closely, these are all positive. Your final results are all positive. So we can write it in this form, n plus 1 into half to the power of n. Now please don't forget there's a 1/4 here. So you need to multiply this by a quarter. How about the second expansion over here? You have, maybe I use a different color. You have minus 1/3 minus 2 plus x to the power of minus 1. So you have minus 1/3 here. Now you look at this. Now, I don't think I need to do a minus because it starts off with 1/6. Alright, so maybe I just cancel this. Alright, I rewrite it over here. It's 1/6. Now, this is the first, this is when n is 1. This is when n is 2. You realize they are all positive. Alright, so what do you get over here? So you got half to the power of n. Okay. How about this term here? This is 1 over 3 into 1 plus x. Now, you find that the 1/3 doesn't change. Every term you multiply by a third. So maybe, I mean, you look at this. I think this part is easier. Let's concentrate on this part rather than this. We derive the expression, all right, in terms of n by looking at this. So you have 1/3. Now this is when n is 1. This is when n is 2. This is when n is 3. You find that this expression is minus 1 to the power of n. Right? We don't need to write the x because we are only interested in the coefficient. So the x to the power of n for fx, all right, fx to the power n, the coefficient, all right, of x to the power n for the expression of f of x can be rewritten as 1/4 into n plus 1 half to the power of n plus 1/6 half to the power of n plus 1/3 minus 1 to the power of n. Now look at this, there's 1/3 is being factorized out. So we take 1/3 out from this expansion or this expression. So you have 1/3, you have 3/4 here into n plus 1 half to the power of n. Now you take out a third, so this one you must times 3. Then you have half into half to the power of n. And this is minus 1 to the power of n. Now they have n plus 2 is being taken out from these two expansions. This, we already reached this term. All right, this one we already got, so don't touch it. Okay, so we try to express these two in this form. So you find that half to the power n plus 2 is being factorized out. So we do likewise. Over here you have 3n plus 1 half n plus 2. Now this half will make it n plus 1 here, but you want a n plus 2. So you want to multiply by another half. So you have to multiply by 2 to neutralize it. So you have 2 into half n plus 2 plus minus 1 to the power of n. Now these two are like terms, like terms, so you can add them together. So you have 3n plus 3 over here. 3n plus 3 plus 2, you have 3n plus 5. 3n plus 5 into half to the power of n plus 2 plus minus 1 to the power of n, close bracket. So you find that these two expression is exactly the same. So we have shown that the coefficient of x to the power n can be written in this form. We have come to the end of question 2. We hope you learned something through this video, and please continue watching our series. Thank you very much and have a nice day.